Now it's
Yes,
good,
it
sir.
started. Yes, it
Yes, you
started.
can.
Okay, thank you. Hi, Dinesh. Hi, Sanjay. How are you guys?
Yeah, I'm good, sir. How are you, sir?
I am doing good. Thank you. Hello, Sanjay. Okay, so let me share my screen once visual. You can let me know. Guys, are you able to see my screen? My screen is visible?
Yes, sir. Visual.
Yes.
Visual.
Okay.
Visible.
Okay. So, guys, last class I already told you. Yes, last class I already told you. In this class, we will start from the NRC part. Okay. From the NRC, we will start. And NRC, again, I am telling you, it is the core routing part. Core routing means on all the routing like EIGRP is there, OSPF is there, and BGP is there, MPLS is there, and your completely VPN part. All the VPN parts, some parts are in the NCore, but the complete part will be in the NRC. Okay, and here in MPLS, it was only the description as per your Cisco syllabus. But what we will do the complete lab here. Okay, like the BGP to MPLS, the redistribution, everything we will do it here. Okay, in the MPLS, and the BGP and MPLS both are basic to advanced. Both the BGP and MPLS. Okay, and OSPF also very interesting topic because a lot of time in your environment also in the 50% time I am seeing they are using the OSPF as the internal routing protocol. Okay, BGP MPLS is mandatory, but for the OSPF, a lot of time I have seen 50% they are using the OSPF. A lot of company are also using the EIGRP, but REAP previously, there was a topic REAP. Okay, now it is outdated because of it is the hop count. Okay, guys, anyone can let me know what is the meaning of the hop count?
Number of router count.
Yes, the number of router, the maximum router we can take. And here,
Which one, sir?
sorry, I was in mute. Yes, anyone asked anything?
You said here you said for which one, sir?
In the REAP, okay, REAP is already it's outdated. Reason right now it is not in the our course, but whenever I will do the redistribution part, okay, there I will let you know what is the working principle of REAP and how it is working. Okay, the main reason it is outdated because it is only the 15 on 16 hop count. When you let it will be the poison. Poison means it will not work. Okay, so let's start without wasting our time. From today we will continue our class. Okay, first I will start from this one, EIGRP. Okay, what I will do, EIGRP first 2 to 3 class will go a little slow, but then we need to repeat it up. So what I will do it today, EIGRP I need 3 to 4 class. A lot of stuff are there in the EIGRP because the actual filtering part you need to understand from the EIGRP only, because when I will go to the BGP part, you should understand all the things about the route map, about the SCL, although you are quite clear about the SCL from your CCNA, but I will explain you. And the IP prefix list, how it will be work. So everything, the filtration and the summarization. Okay, this part you need to learn from the EIGRP only, so that whenever I will go to the BGP part, MPLS part, and OSPF, everywhere this topic will be there. Okay, so it will be quite easy for you. So guys, any doubt? Else I will directly enter into the syllabus, the EIGRP part, because last class already I told you about the NCore and NRC difference. So this time we will start from the EIGRP part. Guys, any doubt? Or I will start from the EIGRP.
Nothing else.
Okay. Let's start from the EIGRP part. Let me see here. Okay. Okay, so what I will do first, I will let you explain about some theory part about the EIGRP. Okay, because whenever I will enter into the interview, already I told you, let me tell you again. So suppose your first part will be in the resume, it is written as EIGRP user expertise level. Maybe you have written as the L2 expertise or L3 SME, whatever you have written on your CV. Okay, maybe you are L2 SME or L3 SME, whatever, or you are an architect level. Okay, but the question will be asked, they will from starting it from the EIGRP, they will directly not give you a lab to do. Okay, or they will not directly give you a scenario based questions. Okay, before that, they will start some basic theory, maybe 2 to 3 liners. So on that case, what you need to do, you already did your CCNA. Okay, and I know you know all the parts of this CCNA, all these theory about the EIGRP. But in this class, what we need to do, first I need to revise all the things. Else, whenever I will go to the lab, let me show you the lab. Okay, because the lab is something little bit difficult in this NRC. It will be a bigger one. Let me show you the diagram, which one we will follow in our class. Just a minute. Yes, guys, are you able to see? These things we will follow in our class. Okay, this EIGRP lab. And this is little bit a lot of network are there. MD5 we need to do and the 50 Mbps bandwidth path we need to do. A lot of things practical is here. So before that, theory part should be clear. Else, whenever I will put any command here, whenever I will do any kind of manipulation, it will be very difficult for you to understand. Okay, so what I will do today, I will start from the theory part. Then we will enter into the lab. So guys, anyone know any theory part about the EIGRP from the CCNA? What is this EIGRP? What is the use of EIGRP? Whenever you learn into a new technology, first you need to know what, why, how. What is this? This is a routing protocol. Why you are using this? To route our network, to communicate to different network. How we are using it? Through the network command. Okay, so whenever details, all the topics, what, why, and how, I will explain all the topics in the detailed way. But whenever you want to learn into a new technology, any technology, suppose you are working on the SD1 part, or you are working on the SDA part, every time you need to learn what, why, and how. Okay, then it will be very clear for you. So let me explain all the things first, then I will show you the PDF. Okay, we'll start one by one. The first is, it is a EIGRP is the advanced distance vector routing protocol. Okay. Before that, what is the route? How many routing protocol are there? Guys, can anyone let me know what are the routing protocol are there?
RIP, EIGRP.
No, 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 no. These are the routing protocol. Yes, you are good. Divide.
Distance vector,
Yes, very good.
hop count. I mean, distance vector, hop count same. And
Distance count, distance vector. Then have you heard about this link state?
yes, link state, link state. That is
Yes.
correct.
Another one.
Hybrid, I think link state both on hop count.
Yes, this one is the hybrid. Okay. So distance vector is the example of RIP. I already told you. Okay. So this is outdated. We will read this topic when I will do the redistribution part. Okay. Here, why it is the outdated, I already told you it is the 15 hop count, and why it is the distance vector routing protocol. Periodically update is there. Periodically update. What is the meaning of the periodically update? means whether there is changes or there is no changes in the routing protocol, I don't care. I will set the update message there. What RIP send? RIP send the update message. Okay. So whenever I will send the update message, whether I don't care, whether it will be any kind of network change is there in my topology. Suppose there is a network in this and RIP is going on here. Try to understand. Here is the loopback. Here is the loopback. And I am doing some kind of, suppose like this, we are doing a router RIP, then you need to put the network address. Okay. And you can write version 2 and your network address. On all the router, whatever the network you want to advertise, you can do this command. And after that, suppose there is nothing. This is working fine. This is working fine. This link is working fine. Everything is working fine. No addition of the new link. No deletion of the new link. But I don't care as a RIP. I will send the update message. Okay. So this is periodically I will send. This is called your the distance vector routing protocol. And under example, you can tell as the RIP. But what is the links and hybrid? Let me come into the hybrid. Hybrid is the mix of both these two. Okay. So, and what is the main cause of, what is the link state protocol? From the link, you can know. From this link, all the protocol, all the routing means all the network will be advertised. From this link only, I will able to know on my area, on my network, who is network are there. Yeah. Okay, that is from the link state routing protocol. And under example, you can take as the OSPF. Because if you have heard of OSPF on your CCNA, you can see a lot of LSs are there. Like type 1 is there, 2, 3, 4, 5, 6, 7. Okay, this type of LSs are there you are using. What are these LSs called? Link state advertisement. In OSPF, it is the LSA. From this link, we can know everything about my network. Okay, end-to-end network. Through this link, I can know. This is the reason it is called the link stat. Okay, and there is no periodically update. Whenever any changes, it will do. Okay, and now come to the EIGRP part. This is hybrid. Dual it is using diffuse update algorithm. It is the loop free for the loop free environment, and it is the coordination of the both distance vector and the link state routing protocol. Okay. Now the second question will be there. Till now, you know, guys, it's the clear routing protocol. Guys, any doubt till now?
Well, sir, what is the meaning exact? I want to know what is the periodic update. Can you come again, sir, if you can?
Yes, periodic update. Let me tell you.
Oh.
Suppose this is one, this is one, this is one, this is one. In the RIP, what it will do, it will continuously send the periodic update.
But that information consists of which one, sir?
No, suppose all the router, this is the R1, okay, this is the R2, this is the R3, this is the R4. And you are doing, suppose one example I am giving here, you have the, suppose network is 192.1.12.0/24, okay. And here it will be 23.0/24.
Okay.
Here it will be 14.0/24. And here it will be 40, you can take 34.0/24. And you may take some loopback also. Okay, 1.0.0.0/8. You know about the loopback or I need to tell?
Yeah, you said it's a logical IP address for the router. That's it.
Yes, for the logically you can take, but here what I will do for the GNS, I will take as a LAN environment. You know, right now I don't have the LAN environment. Whenever I will do the lab part, okay, I will take this, just need to advertise this network under my routing table. For the, like for the ping, I can see you. For the trace, I can show you. For the neighborship, I can show you because I don't have the LAN environment. Okay, but generally for the logical part, we are taking it. Now come to the periodic part. Suppose on the R1, what you need to do? Router RIP version 2. Then you need to put the network command. This network for the R1, which are the connected network? Could you please let me know?
Connected network is 14.0 and 12.0.
14.0 and one more is there?
R4 and R2.
R4 is there and R2 is there.
Yes.
These are the router. You are correct, but these are the neighbor router. Okay. But again, you can see there is a loopback address.
Yes.
It is also connected. You need to advertise. Otherwise, how your LAN environment will be advertised into the routing part. Okay. So this all the first you need to know what is the connected route. Okay. Connected route means you need to know this part. Connected route means these the route which are directly connected to the router. Connected to the router. Okay. This connected network you need to advertise under any kind of routing protocol. Whether you are doing the REAP, whether you are doing the EIGRP, whether you are doing the OSPF, BGP, anything. This need to be advertised under this routing protocol so that what it will do, R1 will advertise all the routes, this one, this one, this one, that I am connected to this one. Then R2 will advertise this one, and this one, whatever is the network, 2.0.0.0. It will advertise all the networks so that what R1, R2, R3 and R4, what they will do, they will completely exchange their table. Okay. And that table is your come under your topology table. Okay. And from this topology, suppose R1, this part R2, suppose R1 try to reach the 2.0.0.0.0.8. Okay. Could you please let me know which path it will follow? This one or this one?
The first one, sir.
The first one. Okay. So from that topology table, it will retrieve the best route that will come into your routing table. Okay. This part is clear. Here how to do the routing. Now come to the update. Why I am coming is the periodically update on all the protocol. Okay. Hello is there. Hello. What is the hello? To see whether my neighbor is up or it is dead or it is down. Okay. These things they are checking. But in the update, in the REAP, what they are doing, it is the update table, update message they are using for your neighbor communication. So this meaning the update message, what they will do, they will completely advertise their routing table periodically. Okay, means whether I have a change, I don't have change, I don't need. Okay, suppose 1.0.0.0.8 is there, but I have one more network. So that time, what I need to do, I need to update my routing table. Okay. But in this REAP, what is happening? 1.0.0.8 is there since last 60 hours. Okay. Nothing is added, but it is continuously updating this routing table, for which it is creating a load. This is why it is called the periodic update. Now it's clear?
Yeah, sir.
It's clear?
Yeah, sir. Yeah.
Okay.
Even though there is no modification on the router or any network, it will still updating to that next routers, right?
Yes, without any modification, but it is continuously updating the table every time. Okay.
Okay, sir.
Okay. This part is clear. Now come to the next one. So this is the mainly difference between your distance vector and link state. One more difference, the major difference. A lot of time I have seen, they have asked you, what is the difference between distance, means EIGRP, hybrid, and link state. Links, although I will cover it in the OSPF, but just as I am doing this routing part, let me tell you what type of question they are asking. Okay, distance vector and hybrid, this one you know, and the link state. Okay, the major difference, it is knowing as the black hole in the network. There is no black hole. I will let you know what is the black hole in network. Okay, till I am in one area. What does this meaning? I am in one area. I will completely explain you in my OSPF class. But just for basic understanding, you need to know. Suppose this one is a R1, R2, R3. Okay. This is the major difference. And this is under OSPF. Same routing table. Guys, you can take as R1, R2, R3, R4, R5. I'm not writing this one. This one is R1, R2, R3, R4, and R5. Suppose in the EIGRP or in the REAP already I told you how to advertise the network. EIGRP will do the lab. No worry about that part. So what we are doing? Router, EIGRP, 10, network. As for just CCNA, I am telling you are advertising your network. Suppose 10.0.00 and 20.00. You are advertising. So R1 is the connected with the R2 and R4. So whenever any routing, suppose there is a 5.0.0.08 is there. 55.0.0.0/8 is there. Suppose these are the two my LAN environment. Okay. These are the two network connected behind this R5. Try to understand. R1 is getting this two network either from this R2 or from this R4. Okay. But in the topology table, I will explain you what is the topology table, what route should be there. But it may be in the routing table means the best route, either it will be learning from R4 or it will be learning from the R2. Okay. But actually in the next step, it will see this one. But actually where this 5.0.0.8/8 is connected, is R1 is aware about this? Suppose there is any issue with this network. Suppose there is any security concern with this LAN network. Is R1 able to identify where actually this is connected? Suppose in between a lot of router are there. Is it possible? Here a lot of router are there. Is it possible? Because it is getting the update from R4 and R2 only. Okay. So it is not known about. So guys, who is not talking, please mute. Okay. So this thing is not clear. But in the OSPF, what it is doing, I will explain you all these things. This is just the basic understanding I am giving you. All the complete theory will be and lab will be there in the EIGRP and OSPF. This is just the basic understanding about the routing protocol. What OSPF, as per your knowledge, CCNA knowledge, it will be advertised through the link state advertised. Type 1 is there, LSA, type 2. Till now, please hold into type 2. Okay. It will. Can anyone let me know from the CCNA which router is generating the LSA type 1? And which one is the generate LSA type 2? No problem. All the things I will cover. LSA 1 is generated by all the router on that area, and it will be the DR. Who will be the DR VDR? I will explain you. But just for this one, I am telling you, suppose this one is R1, R2, R3, R4, R5. What does the mean actually link state? And under that OSPF is there. What it is doing, R5 is telling that to R1 that R1, I have the connected route this one, and suppose here there is some loopback is there, it will advertise. And R1 also advertise the same thing. R3 is also advertising the same things, and then R5. Every router on that area are advertising their routes to another one. Okay, which one I have connected. So from the R1 on their database table on that area, suppose area 0 it is there, on every router, all other router information is there. So I am not worrying about that. I don't know about the R5. I have the information where 5 is connected. There is no black hole in the network, but here it is not knowing, R1 is not knowing where R5 is actually connected, or 5 network is connected. If any kind of security issue is there, I cannot highlight, R1 cannot highlight. But here the situation is different up to one area. But when the different area will be connected, then that time I will let you know. Again, this will be the black hole in the network. Okay, that thing I will let you know in the OSPF class. But till now, guys, clear what is the distance vector, what is the link state, and another one is there, that is the path vector. That is under the BGP. Guys, who is not talking, please mute.
Sir, everyone is mute. I don't know where now noise is coming.
No, yes, now it's good, I think.
Yeah.
Yes.
Okay,
Yes.
go ahead, please.
Okay. So, guys, and path vector is there. Okay, path vector that is under the BGP, because from the path, from the AS number, from the path, we are using this BGP, and we are mainly the purpose of BGP for the path, the AS, different AS communication. We are using the route for the path to manipulation all our attributes. Okay, this is under the path vector. Now, guys, it's clear. Distance vector, link state, hybrid, path vector, all is clear.
Sir?
Yes,
You
go ahead.
said about the difference between the distance vector and EIGRP on that. You said there is no our router 1 will not highlight to our router 3 about the information you said, right?
In the no, this is on the OSPF and EIGRP, I told you.
EIGRP one, yeah.
Yes.
Okay. There is some black hole you said, right, sir?
Yes. What does that mean? You want me? I want to repeat. I should repeat one more time. You want?
Yeah.
Okay.
I want to know exact what is the black hole between them. I can understand from the OSPF, it will know that everything is in a single area means they can understand about that R1, R2, everything. They know the mutual understanding between them.
Yes, it's not okay. Let me tell you again. Okay. In the OSPF, what they are doing through the LSA. Link state, they do the advertisement under the link state. Means whenever R1, R2, R3, R4 and R5 is there, whatever the connected route, maybe 10, 20, 30, 40, whatever the connected route, they all share with each other under one area. Suppose these are in the area 0. Okay. On one area, if that will be the different area, the scenario will be different. Okay. On one area, they are sharing everything that is through the LSA1. Okay, every router is generating LSA1. So what is there? R1 has all the information about the R5. Actually, this router is where it is connected through the LSA1 table. If you will count to show IP OSPF database router, this is the command to see the LSA1. From there, you can see advertised router, which one, what is the connected route, everything. R1 is the information, complete database on one area. But here the scenario is different. It will know for the R5, suppose here is the 5.0.0.0.8, directly it will not advertise. It will either it will be through next up. Suppose this one is the R4, either it will be knowing through R4, because there is only one, so it will be only known through the R4 that I have 5.0.0.8 network in my routing table. But where actually it is connected, suppose for 5 routers there, it is not ever about this. Suppose there is a security constraint in this network and I want to remove, R1 is not ever about this part. Now clear, because here there is no complete database of all the router with R1. This is the black hole in the network. Black hole means I don't know about. I'm completely black.
Okay,
but
what you're trying to say, if R1 trying to reach R3 means it has to communicate between R2, right?
R1 suppose communicate with the R5, it will the next stop, it will learn all the things in the EIGRP through the next stop only.
Okay.
Which is the next stop of R1? R5. Or
So
this one.
After learning that R4 to R5, the R2 will not understand the entire network of R5, right? Even though.
No, it is not the complete database.
That is a black hole, right?
Yes, that is the black hole, because I don't know where, suppose there is 100 of routers, because EIGRP will support 255. So suppose there is 100 of routers, where it is connected, it is not ever about this.
Okay.
R1. That is the black hole. I am completely black on this position.
Okay, and one more thing about the OSPF side, you said, right, sir? If R2 has to understand R5, have to understand R5,
R2, again, repeat your question, please.
I mean, what I'm trying to say,
Hmm.
if R2 want to communicate between the R5,
Hmm.
it has to travel through R3 to R4 and R5, right?
Yes, maybe depending on the cost, maybe
Yes, okay.
through
Even
this
though
one.
the
Yes.
same scenario in the distance vector in EIGRP, it is also traveling through that next hop router only.
Traveling through next stop, you are right. But here through the LSA advertisement, it
Okay.
has all the table. Whenever I will come into the OSPF part, then that time I will execute this command.
Then I can understand.
Yes. Here I am giving you a brief idea because sometimes people will ask you what is the difference between main distance between distance and your link. Okay. So whenever I will do the EIGRP lab, this will be a means right now I'm giving a brief idea. Okay. The basic things I am telling you. But whenever I will do a lab, then the time it will be very clear to you. Same thing with the OSPF. Okay. Because right now it is not clear what is the SO IP OSPF database router. Okay. When I will put this command, all the information on all the router on that area it will become. Okay. And this also, whenever I will put this command R1, it is the clear information about the R3, R5, R4, R2, R6, R7,
So,
everybody.
once I've advertised every network in my router,
Database table.
so the database will be create that routing table will create a bit automatically from R1, R2, R3.
No, routing table is a different part. Routing table is one. It will derive the best route.
Okay. In the database, it will.
It is the complete database on the LSA one.
If I'm just going to R1, I'm just doing that OSPF router database. It will show every database of R2, R3, R4, R0.
Yes. And database also will be
LSA.
different. Yes, database will be also different when you will put this command as a type 1. And when I put this command, so IP OSPF database router. Sorry, network. Okay. Because in LSA1 it is in router, LSA2 it is the network. Here it will be something different. Here the DR will be advertised. I will let you know on that part. Okay. But this is just the basic idea what is the distance difference between your distance and the link. Okay. Clear?
And one thing you have just specified, routing table is derived based on the best path, right?
Yes, it will be based on your destination path, next stop. Okay. And again, it will be derived from the less cost. Okay. Someone is using the cost, someone is using the metric, someone is using the path. Okay. Which one is the benefit for us? Which I use the least cost whenever you will go to the market. Okay. So first you are preferring the best quality. Okay. With the low price. Am I right?
Okay.
Yes. Same thing in the routing table also they will do. Suppose I have 5 path. Okay. So what they will do, they will go through the lowest cost. Okay. Sometimes the metric will be cost, and in the OSPF like it is cost, and the EIGRP it will be metric. And how they are getting calculated, I will let you know. Okay. We have a formula is there. Clear?
Yeah, okay, sir.
Yes. Okay.
I think
Now,
once we get into that actual parts of
yes. Right now, just as a theory, but because only from the theory you are not able to understand anything. This is the reason.
My notes. That's what I'm just saying.
Yes. This is the reason I have this complete lab. Once I will start the lab, then the time your theory part will be clear. Okay. Anybody is asking anything? Okay. What?
Maybe I don't know who is speaking, but go ahead, sir. I'm just monitoring. There is no one muted, but still voice is coming.
Okay, no problem. Okay. So distance vector and the hybrid one, everything is clear right now. And one more thing, the main thing is the EIGRP. EIGRP is a classless. What does this mean, classless? And RIV V1 is the classful. What is classless? What is classful? We'll go.
Classless means it will take for subnet. I mean CIDR. I think so.
Yes, very good. What does mean classless? Classless means suppose I am doing 10.0.0/8. Okay. So then that time it will be good because it is in the major network, class A. Okay. And I am taking 10.0.0.0 /24. Both will be supported in the EIGRP because this is not under the class A network now. Actually, 10 is under the class A. Okay. But whenever I am do the subnetting, it is coming into the class /24 is under class. It's clear? /24 is under class C. Am I right? Guys, this is clear to you?
Yes.
Yes. Okay. So this is the classless network because it is not under the class A. I am doing some kind of subnetting. I am doing supernetting, FLSM, BLSM, but this will be supported by the EIGRP. But this is not in the condition of the version 1. It will support only the 10.0.0.8. This is the meaning of class full and classless. Try to remember, EIGRP is a classless. And already I told you the maximum hop count, you guys already know, it is the 255. These are the some kind of theoretical question you will get in an interview. This is the reason I am repeating. Okay, 255 is your maximum hop count in the EIGRP. And already I told you this is the classless. So this is the reason it is supporting your VLSM, it will support. Your CIDR, it will be support. And FLSM will be also support. Okay. And AD value. What is the AD value? It is the administrative distance. Can anyone let me know? Lower one will be the preferred or the higher one will be the preferred?
Lower.
Okay. Very good. But one condition, when I will tell in the IP prefix list, then that time I will let you know this condition will not be satisfied. Okay. Higher also will be means so suppose we have a lower one and we have a higher one. Okay. I will prefer the higher one. Reason due to there is some longest matching is there. I will let you know on the prefix list. But as of now, you need to know in the AD value, my lower value will be preferred. Okay. And what is the AD value of this EIGRP? 90. These things you need to know. And this is for the internal. Whenever we will do any kind of external means whenever doing your any kind of distribution. Okay. Means RIP into EIGRP into OSPF. Then that time of EIGRP route under the OSPF, you can see as the 170 and it will be denominated as DEX. Okay. Internal value, it's the 90. But whenever you will do any kind of redistribution, then the EIGRP value will be, AD value will be 170. Okay. These are the theoretical questions. Try to remember this one. Okay.
What is the value of 170, right?
170. That is the external. Suppose I have this route, this one. Okay. Here EIGRP is going on. And suppose OSPF router is connected here. Okay. This is the OSPF segment. And here I am doing the redistribution because if I want to communicate here to here, I should suppose here EIGRP, here OSPF. I need to redistribute EIGRP into OSPF and OSPF into EIGRP. Am I right? Because else there will be no communication. Okay. So what that time do? EIGRP external value, when it will coming to the OSPF, it will be shown as the 170 in your routing table. When you will do the show IP route EIGRP, you can see DEX. I will show you in the lab. Okay, no worry about that part. And DEX, it will be as 170. This is the redistribution. In the lab, we will do and I will show you. Guys, till now this is clear, so that I can remove.
When it comes to OSPF posting,
no, not only OSPF, any kind of routing protocol and it will be redistributed. Maybe it is OSPF, maybe it is BGP, maybe it is RIP. Okay. Whenever a EIGRP route coming into this one through the redistribution, you can see as the 170.
And one more thing, sir. Using EIGRP,
yes,
said they are using OSPF. Means how can it supposed to communicate?
Again, you can tell me.
I mean, right now you can given two examples about EIGRP and even OSPF.
Okay.
They are different protocols actually. Okay.
EIGRP.
So
and
OSPF, yes.
Yes.
In the previous part you have shown, right, that there is a
Yes.
different protocol actually.
Yes. Yes.
How do they communicate between there, even though they are different protocols?
Yes.
Did they?
For that, yes. For that, what you need to do, you need to do a redistribution. In the redistribution, in the NRC, we have a, on every routing protocol, we have the redistribution. Mainly in the BGP when I will do, okay, and OSPF I will do. Complete redistribution part will be there. OSPF into REAP, EIGRP, everything. Okay. Then that time you can understand. But just to let you know what you need to do. Suppose this is the border router. Okay. Suppose REAP and EIGRP, these router are connected there. On this router, your REAP is connected and your EIGRP is connected. What you need to do, go router, you need to go, because here it is connected with the EIGRP. Here it is connected with the REAP also on this router. Okay. So what you need to do, you need to go to that router EIGRP, suppose 100 is going, you need to do redistributed REAP. Same thing you need to go router REAP version 2 redistributed EIGRP. So what it will do, REAP will redistributed the EIGRP and EIGRP will redistributed the REAP. Okay, so the communication will be happen through the seed matrix. There is a concept seed matrix. When I will do the redistribution, you can know. Through the seed matrix means, because when it will go to the REAP has update is there, REAP has different values are there, and EIGRP has the different values are there. So through that seed matrix, because whenever EIGRP will go into the REAP, it will behave like a REAP through this seed matrix and through this distribution, and same things with this one. So after that, it will start the communication, but it will be the an external for this EIGRP. This one is a external. Clear?
Yeah.
It's quite clear, or any doubt? Because but in the OSPF,
external.
yes.
The last one you said, right? External.
Yes, external. In the EIGRP, you can see whenever I will do, you can see the lab in the DEX, you can see.
So the redistribution is nothing but the communication between one protocol to another protocol, kind of. Right?
Yes, different protocol, they can communicate through the redistribution.
Every protocol has the redistribution, right?
Yes, every protocol you can, even if in the static also you can do the redistribution. Even if suppose R1 router is there, okay, and 1.0.0. network is there, slack site, and this is not advertised anywhere. Okay, not any kind of routing protocol, no any kind of static, nothing. Even if you can redistribute this connected one also. This is known as the connected. I already let you know, directly connected. It will be showing the routing table as the C. Even if in the connected route, you can distribute in the OSPF, BGP, every routing protocol. How we will do the redistribution, I will let you know here for the connected one also. Even if suppose I have 11 is also here, and I just want to redistribution this one into OSPF or BGP and don't want to this one. Okay, I can do it. Everything I can let you know on the OSPF redistribution when I will do, but just for the understanding, one routing protocol to different one through the same matrix. Okay, and then the communication will be start. Because a REAP is not aware about this. If EIGRP will come to this REAP, it will not know what is this EIGRP, because REAP is only understand about the REAP, but whenever it will come into the REAP area, it will behave like as a REAP EIGRP. Okay. All the attributes will be behave like as a REAP, and whenever REAP will enter into the EIGRP, same thing. REAP will lose its attributes and it will come into the EIGRP and starting the communication. Clear, guys?
Yeah, sir.
Okay.
The redistribution is another name of CF matrix, right?
No. Redistribution is not the name of seed matrix. Seed matrix is a key concept there. Means nothing, seed matrix is nothing. Just EIGRP attributes will be redistributed on that REAP, and REAP metric will be redistributed, REAP update will be redistributed into the EIGRP area. That is through the seed matrix. Means suppose you will come into my area, okay, so you are suppose you are getting into your office, okay, you are checking something there, okay, and you need to take some kind of your office premises, means like you should have your ID card, you should have means your asset ID like your laptop, that things should be checked. Okay, Same things when you will do the redistribution, REAP will be checked under the EIGRP and it will be under the as a EIGRP metric, it will be there. Okay. So this thing will be done through the seed metrics. It will be quite clear to you when I will do the lab under the OSPF. Okay. Now come to the EIGRP table. These are the theory again. What is the meaning of table? Can anyone let me know?
Table, sir, routing table or?
Yes, some kind of routing table is there. Am I right?
Yes, sir.
But this is also three types of, you may get this question in the interview. Three type of tables are there, not the routing table. Three type of table are there. One of them is the routing table. You are correct, but two are different. But three type of table are executed by the EIGRP routing protocol. Okay. The first one is the neighbor table. Then second one is your topology table. And third one is your routing table. Let me tell you one by one. What does mean the neighbor table? Who is the neighbor of R1?
R2.
R2. Very good. And who is the neighbor of R3? R2. Is R1 is neighbor of R3?
No.
No. So whenever you will go into the R1 and you will type the show IP EIGRP neighbor, okay, then that time we will show the information of the R2 only. In the lab, we will see. But you need to know this is the neighbor table, just a connected router, nothing else. R1 is directly connected with the R2. So for R1, R2 is the neighbor and R2, R1 is the neighbor. So whenever you will go into the show IP EIGRP neighbor, you can easily see in the R1, you can see the R2. And whenever you will enter into the R2 and you will type show IP EIGRP neighbor, the command, then you can see the R1 information. That is the neighbor table, only the connected route. And now come to the topology table. What is the connected router on the R2? What is the neighbor router with the R1? Starting from the R1, who are the neighbor router? Who is the neighbor router of the R1? Am I audible?
Okay.
What are the neighbor router of R1?
R2 and R3.
R2 and R3. Okay. Now, what the topology table? So IP EIGRP topology, whenever we'll tau, it will on the R1. Suppose I am doing this. So IP EIGRP topology. Now, no need to write. Please try to understand all the things. Whenever you will go through your video, then that time you can prepare the note. As of now, just listen and try to understand all the concept, all the technical things. Okay. So IP EIGRP topology. Now come to the R1. R1 is the R2 route. R1 is the R4 route. R1 is the R5 route. Okay. But in the R5, suppose R1, suppose this metric will be less, means you can imagine this cost will be less from R1 to R4 and this one will be the higher one. So R1 from and R5, the preferred route will be this one. Okay, because the cost is higher in the downside. But in the EIGRP topology table, it will register all the one, whether it will be through the upper one, whether it will be through the down part, it will register all the table here, all the routes, all the path. Every path will be here. Whether it will be the best, whether it will be the worst. But what is in the routing table? From this topology, it will derive which one is my best route, means lowest metric. That routes directly come into your routing table. Means only this path will be here. R1 to R5. R1, R2, R4, R5. Guys, clear? What is the difference between EIGRP table, neighbor table, and topology table? sorry, never table topology and routing table. Clear?
Yeah.
Okay. Now come to the next one. Like EIGRP, I told you, suppose this one is there, this one is there, this one is there, this one is there. I need to go this one. Suppose one route is there and 5 route is there. Suppose I am getting the 5 route to this one in my routing table. Okay. Due to the less cost, how it is getting calculated, let me explain these things. You need to know. Whenever you will do any kind of lab or any kind of a real scenario in senior office, you don't need to do any kind of things regarding to this, but you need to know what is the concept behind it, how these metric is getting calculated, how it will be prepared. Okay, everything you need to know what is the background process. Like STP, you are not doing anything on the switching level in the STP, but you need to know what are the concept, how you can manipulate. Same thing you need to know here in the metric. Everything will be automatical. Okay, but you need to know how it is being calculated. So for that, the cost is calculated in the EIGRP known as the metric. To the metric, it will be calculated. And for this, we have a formula. Okay. EIGRP metric will be calculated as bandwidth plus load plus delay plus reliability plus MTB. Once everything will be calculated, suppose here and here, this calculation will be done. How it will be done, I will explain. From this calculation, it will get a value. Suppose from this one, it will get 10 and under this one, it will get 15. So which one it will be preferred? 10? Guys, clear? Your voice is, I think, who is telling this one?
Come again, sir.
Yes, it's very slow. Your voice is slow. Could you please repeat it again?
Dinesh, your voice is very slow. Would it be great if you can speak a little bit louder? It's
From the
very
beginning
hard.
or right now?
Sorry?
From the beginning or right now?
Yeah, from beginning it's very slow. We are not able to understand anything. Means
Yes,
it's a
okay.
slow, like it's very slow.
Yes. Okay. So Dinesh, what is the doubt regarding this? Could you please let me know? Okay. So Dinesh, let me explain you again. So EIGRP is a specific formula for the metric. Okay. That is the cost. In EIGRP, this cost is known as the metric. Any doubt, please let me know sometime. So cost is the metric. Okay. How metric is being calculated? This value. Okay. Bandwidth is there, load is there, delay is there, reliability is there, and M2 is
Hello.
there. Hello, yes.
Sir?
Yes, tell me. Yes, go ahead. Go ahead, Dinesh. You are not audible.
Sir? Hello?
Yes, yes, tell me. Go ahead.
Hello?
Yes,
Hello?
yes, you are. Please tell.
Hello?
Yes, yes, Dinesh, you are audible. Please tell.
Sorry for that. My audio has been disconnected. So one second.
It's good now. I should explain.
One second.
Okay. Other people, it's clear. I think someone is IBS is there.
You can
Some
hear
other
me,
guy.
right, sir?
Yes, yes. Dinesh, you are good now. Tell me.
The voice is perfect right now, if you don't know.
Yes, yes, yes. It's
So
good.
yeah, sorry for that, sir. The voice has been
No
disconnected.
problem. No problem. Tell me.
And yeah, you can explain again, sir, for that. Sir, for what
You
can-
want me to explain again?
Yeah, sir, because the voice has been disconnected.
Okay. Okay. No problem.
Hmm.
So what I am telling, suppose this one is the R1 already I told you.
Hmm.
And suppose here one network is there.
Hmm.
Here two network is there.
Hmm.
And this one will be the root. This one will be the root. I have two root from R1 to, suppose this one is R2, this one is R3, this one is R4. R1 to R4, I have two root. Am I right? It's clear.
Yes, sir.
But I will be only in the routing table. How many routes will be there? Only one path. That will be the best one. How the best will be calculated? That will be through the less cost. Cost is known in the EIGRP as the metric. How we can calculate the metric? There is a specific formula. You don't need to do anything. Okay. Everything will be in the background process. Okay. You don't need to do anything, but you need to know how it is being calculated. Okay. If you are giving the interview, if you are doing any kind of manipulation is there, if you are giving the lab, then that time you need to know how this value is being calculated. Okay. For that, we are using bandwidth plus delay. You can count bandwidth plus load plus delay, K value, plus the reliability plus the MT. These things we need to calculate. Okay, how we'll calculate, I will explain you. Once you will calculate from R1 to R4 and R1 to R4. Suppose here you are getting 10. Here you are getting 15. How it will be calculated? From this value only. You need to remember this one. Bandwidth plus load, delay, reliability, and MTU. Okay. Again, I will come to the exact calculation. So on the upper path, if you are getting the metric as 10, and in the down path, it will getting the metric as 15. So I have my routing table. This will be the preferred one because of the lowest metric. It's clear?
Okay.
It's clear?
The cost will be calculated based on that which one, sir? I mean that the 10 and 15
No,
will be
cost
decided
is
which one?
cost term is known as in the EIGRP as metric.
Yeah. That's what I'm saying. You just
Yes.
mentioned two things, 10 and 15, right?
Yes, 10 is
Which
the
one will
metric.
be, yeah. Which one will be determined that number, sir?
It's the metric. It's the
No, no.
metric.
Yeah, that's what I'm trying to ask as a layman.
Hmm.
Yeah, between R1 to R4, there is a two path, R2 and R3, right?
Yeah,
So
R1, R2,
from
R4.
R1, if R1, yes, okay.
R1, R3, R4.
R4, yes.
Two path.
Yeah.
Path number 1, path number 2.
Yes. For the first path, you're saying 10. Number metric value is 10. Okay.
10. Yes.
For
I am
the
not
second-
calculating this one for
It's
an
automatically.
example. Yes.
Yeah.
Example I am giving.
In
Yes.
second path, it will taking 15, right?
15. Yes.
How it's calculating that? It will be taking 15 and 10. And based on that, that's what
From
I'm
this
asking.
formula,
Okay.
I will in the bandwidth plus load, delay, reliability, MTU. Everything I will let you know what are these terms. Okay. And how it is being calculated. As of now, these are this parameter you will use in this EIGRP: bandwidth, load, delay, reliability, and MTU.
Okay.
Once it will be calculated, we have a specific formula. I will explain you. So then it will calculate the cost. I have two paths here, and it will get the metric as 15 here. So it will be the bigger one. Lowest one will be the preferred. Lowest cost will be the preferred. Here it's metric. So my upper path will be preferred.
Yeah, okay. And there is a slight doubt on between the topology table and routing table. In topology table also, you have said, right, sir, it will also choose the best path, right?
No, topology table is a different one. Let me tell you again. Neighbor table is clear?
Yeah, neighbor table is clear, sir.
Topology, it's not clear. Am I right?
Oh, yeah.
Okay. One more is
Topology,
routing.
what I'm there is a doubt.
In
topology table, while concluding, you said it will choose the best path for that.
No, in the routing table, it will be choose the best path. best route in the routing table. Suppose in the topology table,
Hmm.
suppose this one R1, R2, R4, R3.
Hmm.
Okay. How many route? R1 to R4, R1, R2, R4.
R2, yes.
R1, R3, R4.
Ah.
2 routes,
Yes, sir.
2 path. Am I right?
Yes, sir. Yes, sir.
In this topology, every possible routes are in the topology. Every possible route. What does mean every possible route? Whatever is the route, suppose there is another path, another path, another path. Every path will be restored in my topology table.
Okay.
Every path. And in the routing table, the best path, the less cost. Suppose out of 5, one of the cost is 10. And other are 15, 20, 25. So this 10 path will be in this routing table. This is the best. Once this will be filled, from the topology table, it will see which will be the second best. For that, there will be something different. I will let you know. From that topology table, it will retrieve to the routing table. Routing table only one, the best route. Here, all the 5, 10, whatever the routes here there on that topology, all the possible route. Clear?
Okay. Yeah.
Okay. Okay, where I was there?
We have concluded 3 things, sir. Routing table up to.
Yes. Then I told you this one, EIGRP metric.
Yes, sir. How it will calculate, you said.
Yes, how it will be calculated, I have already said. And as of now, what we have covered, EIGRP, all the basic theory. Okay. And then, yes, then I have covered whatever the distance vector.
Yes.
And your hybrid.
Link state.
And your link state. Major difference between OSPF and EIGRP is just basic overview. Okay. And how the metric is being calculated. This is the first formula. The final formula is there, the best one. Okay. Which value you need to do. Okay. Bandwidth, load, delay, reliability, MTU. And what is the AD? Which AD will be preferred? And what is the external? What is the internal? Everything I have covered in this class. Okay. On the next class, what we will do? Next class, I will do the exact calculation. And right now, 1 to 2 class, we will go in a slow way. Just for your means good understanding. Then we need to repeat it up. So in the next class, what I will do, how it is being calculated and how we can do our fast lab. Okay. The bigger one of what I have shown. But these things is quite important, the calculation part.
Okay.
Okay. So guys, you are available for the means tomorrow or Sunday, because it will be very good if you can continue this class for 3 days. Because you know, right now you are here, bandwidth, delay, roll, reliability, MTU. So if I will start from tomorrow, then it will be very good. You can easily understand. You are available just
tomorrow only or Sunday included, sir?
If we can complete this topic, then again we can break the Sunday, then we can start from Monday. But if it's up to you how guys you are comfortable. For me, just for the as it is the first one, EIGRP, fast protocol. So we should continue because it will be very good. You cannot means you should remember all the things. There will be no hesitation, nothing. So it will be very clear understanding if you can continue. But it's up to you. It's your class. Full flexibility is there. So you can let me know if we can continue these two. Then we can in the weekdays, if you want, we can for the practice, you can take 1 day gap. It's not an issue. Just for the continuation, I am telling you, but it's up to you. Tell me. We can start earlier, means around 8, 7:30, 7. If you are available
actually, I haven't another schedule, no problem. But I can choose based on the people, based on their voice.
No, it's up to your class. If you want to close this class, We'll start on Monday. It's okay. But
No,
just for the
right.
continuous.
Manas sir,
Yes.
let's continue this class by 9:30 as per schedule for time being. Later we'll decide, okay? If
Okay.
it is need to be done anything, okay? Might be other people have a problem, okay?
Okay.
So for time we'll just go for 1 hour, 9:30 to 10:30, and later we'll see after 1 week we'll decide, okay?
Okay. So tomorrow we can continue or we can.
We will have to do this Monday to Friday, so we'll
Okay.
continue Monday. That is going to regular now onward. No further
Okay.
any disconnections.
So
Okay. No problem.
the tomorrow will be available or not, sir?
Tomorrow, Saturday, Sunday is a holiday. Okay, Dinesh.
Yeah,
So
thank you.
this is the Monday to Friday regular class is going to happen.
Yeah, and that is what I have a doubt, sir. I want to make sure on few things on these classes. And how do I gonna access that Zoom link? If there is no
Yeah,
portal is
you are
available.
going to get Zoom link. From next week, it's a permanent Zoom link. So you have to join that Zoom link only. Just
And
allow,
where
yeah.
it will be available, sir? In the portal?
It's yes, it is going to be shared by Monday to you, and meanwhile you're going to get from the your message, okay? But later you will get the permanent Zoom link, and you have to keep that Zoom always, and that is going to use always that for class.
Okay, sir. And for the practical lab, how do I access the
Yes,
lab?
lab access also you're going to get by Monday or maybe tomorrow, okay?
And one more thing, sir, if you don't mind, can we create a WhatsApp group also if we
Yeah,
have any doubts?
definitely. We can
Because
create.
if there is no class, if sudden break has been happened for
Mm.
Manas sir, if they are scheduled trapped with another call means if there is
Yes.
no
Yes.
class, everyone should know, right? That's what I'm asking.
Definitely, Dinesh. It is going to have. It's a very flexible, so we'll create a group as well. No worry, okay?
Okay,
But
sir.
for time being, it's a session
Even
is
though if they have any doubts on the group, we will discuss on the group for that.
yeah,
Yes.
sure.
Yes. Yes. Yes.
Sure.
Yes. Will do.
And thank you for that, sir. So right now we are concluding, right?
Yes, I am concluding. Any doubt? Any other person?
No, sir. We will once we go into the practical classes, then only we will where there
Yes,
is a
yes,
huge
yes,
doubt will
yes.
be rising. Okay.
Yes. Next
And
class, almost one more theory class. Then I think on Tuesday we'll enter into the lab.
yeah, okay, sir.
Okay.
Okay.
Okay,
Thank you for
then.
that, sir.
Thank you. Thank you.
Mm.